Hello, my name is Stephen Summerlad, and I'm going to be explaining problem number 20 on the diagnostic test. As we can see, the problem says, in a right triangle, ABC, the tangent of angle A is equal to 3/4. And we are required to find the sine of angle A and the cosine of angle A. Before we begin actually working the problem, it would be a good idea to review the basic definitions of the three fundamental trigonometric ratios, the sine, the cosine, and the tangent. So let's begin by writing those down over here. The sine of angle A would be defined as the ratio of the side opposite angle A to the length of the hypotenuse. The cosine of angle A would be defined as the ratio of the side adjacent to the angle, again divided by the length of the hypotenuse. And finally, the tangent of angle A would be defined as the ratio of the side opposite the angle A to the side adjacent to angle A. And also as a reminder, these definitions can be remembered by the simple little mnemonic device, Oscar had a heap of apples. So if we're ever in a situation where we can't recall those, we can remember that little mnemonic, and it works like a charm. Sine, cosine, tangent, Oscar had a heap of apples. Now that we have the basic three trigonometric ratios defined, the next step is actually to draw a picture of triangle ABC. And let's keep in mind that it is a right triangle, and a right triangle is defined as a triangle that contains exactly one right angle. So let's go ahead and draw out that triangle, and let's put in the symbol right here for a right angle. And we can label the triangle. Let's label it this way. This is A, B, and C. It really doesn't matter, but it might be a good idea to put the angle down here and make it a little bit easier to work with. All right, so it is angle A that we are working with right here. And so the next step would be to label the opposite, hypotenuse, and adjacent sides to angle A. I always like to begin, and I suggest this to make it a little bit easier, to start with the angle and go directly to the side opposite that angle over here and put a little O on the inside of the triangle. That immediately labels this the opposite side to the angle. The next step should be to label the side opposite the 90-degree angle as the hypotenuse. And we want to remember that the hypotenuse is always the side opposite the 90-degree angle. Now, by the process of elimination, the remaining side must be the adjacent side. I always find it easy to locate the adjacent side by simply using the process of elimination after you've labeled the opposite and hypotenuse. All right, now, it is telling us in the problem that the tangent of angle A is 3/4. So let's write this down over here next to this definition. That would be 3/4. That tells us that the opposite side then must be 3 units long. So coming back to the diagram, I'm going to put a 3 next to the opposite side. This also tells us that the length of the adjacent side must be 4. So since the adjacent side is here, this would be 4 now. In order to find the sine and cosine of that angle, we're going to need the length of the hypotenuse, which clearly we do not have here in the right triangle. So, in order to find the length of the hypotenuse, we'll be using probably one of the most famous theorems in geometry, and that is the Pythagorean theorem. That says that the square of the length of the hypotenuse is equal to the sum of the squares of the other two sides. So why don't we call the length of the hypotenuse x, and let's go ahead and write that out in the Pythagorean theorem. The length of the hypotenuse x, and then we're going to square it, is equal to the sum of the squares of the other two sides. So this would be 4 squared plus 3 squared. Again, the square of the hypotenuse is equal to the sum of the squares of the remaining two sides of the triangle. Now we can just go ahead and solve this out. X squared then would be equal to 4 squared, of course, is 4 times 4, which is 16. And 3 squared is 3 times 3, which is 9. And adding 16 and 9, we get 25. In order to solve this, we're going to take the square root of both sides. So the square root of x squared would be equal to the square root of 25. This, of course, is taking the square root of both sides is a standard technique for a very simple little quadratic equation like this. The square root of x squared is x, and the square root of 25 is 5. So that tells us then that the length of the hypotenuse is 5. Going back up here to these definitions, we can now fill in the missing figures. The length of the opposite side is 3. We now know the length of the hypotenuse is 5. Therefore, the sine of angle A would be 3/5. For the cosine, we need the length of the adjacent side, which is 4. And once again, the length of the hypotenuse is 5. And the cosine of angle A is 4/5. And as we can see, we've answered the question with our answers. Thank you.